Okay, so continuing in our last video for section 3.2, we're talking about synthetic division. We talked about in the first video how to do synthetic division. The last video we talked about the remainder theorem. And now we want to talk about testing potential zeros. So a zero of a polynomial function is a number k such that f of k equals 0. So let's think about this for a second. If we were to take a simple function, let's just say 2x plus 3, if we were to set that equal to 0, then we could solve for x and we could say, oh, well, x is whatever number, right? If you think about when we solve quadratic equations, we would take a quadratic equation and we would set it equal to 0 to be able to find what x is. Well, that's basically what we're talking about. If we can take a function and set it equal to 0, then when we solve for x, we're going to find f of x equals 0, right? Because f of whatever x number we put in should give us 0. And so what this is telling us is that if we were to go through our synthetic division and we test a number, if we get a remainder of 0, then we know that that number is a solution to that equation. It is a 0. If you think about the graph, it's where it crosses, or where it touches, the x-axis. It's the x-intercepts. So, for example, on a parabola, if you were to look at the graph of a parabola, when you solve a quadratic equation, you're looking for these 2 points. Those are your solutions, because if the equation, again, just make one up here, if it's x squared plus 5x plus 6, well, the solution to that are going to be points that are on that x-axis, because we would say, well, that's equal to 0, right? Well, when I take those x values and put them in, I'm going to get 0. And so the order pairs are going to be 3, 0, or 2, 0, or whatever the numbers might be. And so we're looking for these x-intercepts, these zeros. And so this synthetic division, based off the remainder theorem, is going to allow us to test quickly to see if a number is a 0. Because if it is, then we got to get 0 for the remainder. It means it divides evenly into that function. And if it divides evenly, then that number has to be a solution, or a root is another way we can talk about solutions. So a 0, a root, a solution, they're all the same thing, just a different way to say it. So let's try a couple and see if numbers are solutions to the equation. So here it says to decide whether the given number k is a 0 of f of x. So you clearly see what f of x is. The number that we're going to try is the 2. And so we're going to do our synthetic division, and we're going to see if maybe we get 0 as a remainder. If we do, that'd be great. Now, again, notice that in the function, we start with x cubed. We have x squared. We don't have an x term. And so we need the 0x and then the negative 18. And so in our synthetic division, we got to put that 0 in. And so we have 2, negative 3, 0, and then negative 18. Okay. And so we'll go through our synthetic division. Again, bring down the 2. And then 2 times 2 is 4. Negative 3 plus 4 is 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 18 plus 4 is negative 14. So to answer this question, since our remainder is negative 14, we would say that 2 is not a solution of f of x. It's not a solution of that function. So again, very quickly we can tell, okay, that number didn't work. Now, later on, we get into section 3 and 4. We're going to talk about, well, how do I know what are possible zeros, possible solutions? There are some ways to kind of narrow that down. But here, we're just testing to see, is this number a solution? If it is, we should get 0 as the remainder. If you have questions about that, let me know. So I'd like you to try this one on your own. Again, pause the video, give you 3 seconds to do that. Okay, so hopefully you pause the video, you tried this one on your own, and you're able to tell if it is a solution or not. Now, -3 is the number we're going to use to divide by. We're wanting to know, is -3 a solution? And if you look at our terms, we have x to the 4th, x cubed, x squared, x, and then our constant. So we have every term. There's no 0 that has to be put in because there's no missing term. And so our coefficients are 1, -4, -14, 36, and 45. And so again, we want to just do our synthetic division quickly. So bring down the 1. 1 times -3 is -3. -4 minus 3 is -7. -7 times -3 is +21. -14 plus 21 is 7. 7 times -3 is -21. 36 minus 21 is going to be 15. 15 times -3 is -45. 45 minus 45 is 0. So, because our remainder is a 0, that does tell us that -3 is a solution to this equation. And so we would say just that, -3 is a solution.